Okay, so let's take a look at question 10, shall we? So Cub, the question first of all, please. So Sally's taking part in the archery competition. She transfers 1 joules to elastic store. What's the maximum possible? Okay, so this is a slightly different version of a calculate. What is the maximum possible kinetic store of an arrow after it's released? And it's worth 1 mark, so it's going to be a fairly straightforward answer. It doesn't say calculate because you don't have to actually calculate anything. So what you have to do here is you have to recognise that, that Sally transfers 500 joules to the elastic store of the bow, which is then released and transfers its energy to the kinetic store of the arrow. So if we look at what's going on here, we've got the bow, so 500 joules elastic store, of bow, and what's happening is that is being transferred to, so when that bow is going off, the kinetic store of arrow. And also remember, we always get a thermal store of what, of everything really, a bow, arrow and surroundings. So if this is 500 joules, transfers along a pathway, in this case that pathway, it's a force, so it's going to be mechanical work done. That's the pathway. The maximum possible kinetic store of the arrow after it's released, well, the maximum possible would be that. Would be if it was 100% efficient and it didn't waste any energy at all, then the maximum would be 500 joules. So what you're doing here is you're being asked, can you recognise the fact that the law of conservation of energy tells us that the energy before a situation must be the same as the energy after a situation, and that energy is merely transferred along pathways from one store to another. Okay, so the maximum possible store there, and there's a clue there that it didn't say calculate in the question, which means you don't actually have to calculate anything at all. So the maximum possible for that question would be 500 joules. In reality, of course, it would be less than that, because some of that 500 would go here as well. Okay, so a follow-on question that often comes is, suggest why in reality the kinetic store of the arrow is far less than this. Well, and the reason being because some of the energy is transferred to the thermal store of the bow, arrow and surroundings. Okay, let's look at part B. Could you circar this question, please? So it's a calculate question. Maximum speed. Use the equation. Kinetic energy is 0.5 mass times speed squared. That's worth 5 marks. So this is going to be this 5 marks. This is as difficult a calculation as you're likely to come across. Sometimes in higher tier you may come across more complex equations, especially in physics and electricity. But for now, this is probably right up there with the hardest sort of calculations you might find. It's also using one of the hardest equations that we use in physics, kinetic energy equation, which is 0.5 times mass times speed squared. I'm going to copy down our values, rewrite our values. Using my shopping list here, my equation as a shopping list, I'm looking for the maximum speed, so I'm going to calculate speed. So what does it tell us? Well, it's already told us that the kinetic energy, so kinetic energy store is 500 joules. If I didn't know this from the question before, but I know that because I'm working at maximum speed, so I'm working at this one here, I could always make up a value for kinetic energy if I didn't know one already. I could just put one in. So even that'd be fine, because I'm only going to get penalised once for not knowing the answer to this question. Okay, they call that error carried forward. So there's my kinetic energy, 500 joules. 0.5, well I know that. Mass is equal to 100 grams. Well, 100 grams is an unusual value, isn't it? I'm going to convert that straight away. So I need 100. I've got a number that when I divide it by 1,000 gives me 100. So 100 divided by 1,000 gives me 0.1 kilograms. So my mass is 0.1 kilograms, and that will be worth 1 mark right there. So I've got 1 mark already. I'm going to substitute my values into my equation. So I'm going to write kinetic energy equals 0.5 times 0.1 times speed squared. Now I don't know what this is at all, so I'm going to write S squared. I'm going to put my values in first before I try and rearrange anything. And in fact I knew the kinetic energy, didn't I, as well, so let me just rewrite that again. So it's 500 is 0.5 times 0.1 times S, that should look like an S squared. This is sometimes why we use, instead of S, we often use the symbol V for speed and velocity. I'm going to do as much of the maths as I can before I start rearranging. So 500, 0.5 times 0.1 gives me 0.05 times S squared. Now I'm going to rearrange. So I'm going to make S, the brackets, S squared, I'm going to make that the subject. I'm going to bring it to this side. So S squared, I'm going to bring everything in the brackets to this side, is equal to, so 500 divided by 0.05. And then let me just work that out quickly. 500 divided by 0.05 equals 10,000. 10,000. So I've done enough right now to get 4 marks out of 5. There's one thing missing, and that one thing is I've still got S squared. So I need to get rid of the square, so I need to square root both sides. So S is equal to the square root of 10,000, which gives me a total value of square root of 10,000 equals 100. So my value there is going to be 100, and this will be in meters per second. In terms of the marks for this question, 1 mark for the conversion. I'd get 1 mark for getting to here, the S squared value. I would get 1 mark for the substitution, which I've got here. I'd get 1 mark, so that's 3 marks. I'd get 1 mark for the answer and square root correctly. And finally, I'd get 1 mark for rearranging. So that's here, isn't it? Rearranging to get S squared. Okay, so lots of marks available for that question. The important thing is to do it in a very, very methodical, stepped way, and don't be scared about writing out extra lines of working out. That's absolutely fine. The important thing is the examiner can see exactly where to give you the marks. And if you try to jump straight to this question, the answer here, chances are you're going to make a mistake. And if you do, the examiner doesn't know, did you correctly substitute the numbers in? Did you correctly rearrange the equation? It might be that you actually did everything correctly except for writing down the value off your calculator because you were in a bit of a rush. So take your time, get all the marks. Right, hope that was useful. Take care.